Electric cars are about to make up 5% of new cars sold in the United States. Once they pass this mark, they will move beyond the early adopter stage of a product life and quickly enter the mainstream. But electric cars have one big problem that's very easy to solve, but no one's doing it. To better understand the problem, we need to look at how electric cars get their power. The most basic way of transferring energy to an EV is to plug it in. But what you plug into is what matters. There are 3 levels of charging, and the level that you connect to impacts how long it takes your car to charge and how efficient the charge is. When charging an EV or any electric device, there are 2 things that matter: volts and current. Volts is the pushing force on electrons, and current, measured in amps, are how fast the electrons are flowing. To find out how fast the charger is, multiply the 2 numbers together and you'll get how many watts a given charger can provide. For example, a 120 volt outlet provides 10 amps of power will produce 1.2 kilowatts of energy. If you have a 400 volt source at 150 amps, that will produce 60 kilowatts of power in an hour. Now, on to the 3 levels of charging. Level 1 charging is the most basic and easily accessible. Most EVs come with a mobile charger that connects to a standard 120 volt outlet. Sometimes called trickle charging, level 1 chargers can add roughly 3 to 5 miles an hour to an EV car's range. What it has in availability, it lacks in speed. Level 2 charging is the most common type of charger that you'll see around. You have them installed at your home, you'll see them outside of businesses, shopping centers, grocery stores, etc. Amps in a level 2 charger can range from 12 amps all the way up to 80, meaning that at the 240 volts that they run at, you can charge 3 to 19 kilowatts per hour of charge. Most level 2 chargers add about 25 to 30 miles of charge per hour. Level 3 charging comes in at 400 plus volts. They can be found at dedicated locations because they require tremendous amounts of power and equipment to operate. Often called DC fast chargers, they can add 50 to 400 kilowatts per hour, meaning that you can add hundreds of miles of energy to the car in a short time. For example, Tesla says that in 15 minutes you can add 200 miles of range to your car. Now, we haven't talked about the problem at all. Remember when flip phones were all the rage, but every type of phone had its own unique charging connector? That's what's happening with electric cars in the United States. Currently, there are 4 major types of connectors at play in the United States: the J1772, a Tesla charger, a CCS1, and a CHAdeMO. Depending on your manufacturer, you may be able to take advantage of some of these or one of them, depending on how the car is set up. A non-Tesla will not be able to charge at a Tesla supercharger because of the connector. A Tesla is not going to be able to charge at an Electrify America charging station because they don't have a connector that fits either. While adapters do exist for these, they are expensive and often do not handle payment handoff systems needed to verify the charge. So what do we need to do to solve this problem? We need to pick a standard and go with it. That's as simple as it gets. While each of the connector types have their own pluses and minuses, having one standardized connector will make the EV experience much easier and more useful. For instance, when you go to the gas station, you don't have different size gas pumps per car. You have one standard connector that allows all cars to get fuel on the same pump. And that's it. The solution to electric cars' most solvable problem is a standardized connector that allows cars from any manufacturer to charge on any charging station anywhere.